You're reading. We've only got 2 people here. All right, so I'm assuming you guys have read. So we've got 200 east and 100 up. So 200 out here, 100 up. We've got the plane and it's sort of heading in at this direction. It's coming in at -3, -1. It's always a good idea to picture everything and draw them in. And it says it's flying parallel, same direction. It's got a speed of 4 root 10. So write down the velocity vector. So at the moment, if you just wrote -3, -1, that does not have a magnitude of 40 root 10. What's the magnitude of this one? Root 10, okay? So that's no good. We want it to be 40 times that. So therefore, that makes our velocity vector equals to 40 times -3, -1, which will then be -20, -40. We happy with that? Yep. A, done. Okay, we then hit on with B. Write our vector equation for the path of the aircraft since 12 o'clock. Groovy with that. So that will be, I might come up here now. No, I'll stay down here. So our vector equation, hey, now there's 4. X, Y. Any takers? Have you done this one? You've done this one. We'll carry on in a minute. So what was our initial points, did we say? I didn't label it, which is bad, but where did we say we started? 200, right. So again, if it had been labelled, it's going to be a pretty easy thing to go through. So that's going to be 200, 100, plus t, and we've already found our velocity vector. So pretty groovy. And it's since 12 because we said that's where it was at 12 o'clock. Now, I would put a little bit of a star next to some of these questions because when we're doing our investigation, we've got our mosquitoes flying. They're going to start at a particular point after a certain amount of time. They're heading off in bits. I mean, I'll remind you, so no worries. But anyway, so we're carrying on and, you know, they're setting you up with these about how you can do one question, it goes into the other. So we've got our vector here. This is representing the position of the plane at any time. It's now saying find the position at 1 p.m. In other words, how much time has passed? 1 hour. So for part C, you're just going to sub in t equals 1 and we'll get our position of 200 plus 1 times -20. So that will give me 80. And 100 take, so 80, 60. Simple sub. On the radar screen at 1 p.m. Now again, make sure you're looking at what you've just done. So at 1 p.m. we've said that it is at this position. Why is it visible? Because it's in the It's either going to be inside the circle or it's going to be on the circle. And therefore, so how many different ways can we do this? Yeah, well, yeah, because in this case, because it's from the center, the tower there is at 0, 0. Yes, we can just work out the magnitude of that and get it. If the tower wasn't at 0, 0, what would you then do? Let's say the tower was at 10, 0. Right, find the vector, find the vector between the 2 points and then find its magnitude, okay? In this case, we're going, yes, because it's 0, so we can say from the tower to the plane, P for plane, position. Can we say T for tower? So PT, TP, TP will be 80, 60. We find that magnitude, it is 100, so anything that was 100 or less, hello? Sorry, you go on. Anything that was less than 100 or 100 means that it's on the radar. If this was a test question, I would then be writing that down and putting my thinking and saying it must be either 100 or less than. Find the time taken when the aircraft is closest to the control tower. So once again, this is the actual thing that we've been doing. Everything up until this point is old vector news. This is now the closest point. Agreed? All right. Indy, you're happy to go on? I'll come and get you started on the equation of a plane thing in a minute. Okay, so what have we got going? We've got the plane coming in. Let's go here. We've got the plane coming in like so. Plane. And we've got possibly the tower over here. I'm not very good with my, let's go that. It's my tower, 0, 0. So we want the closest point. And so what we have to do, let's say this is the P, the plane. We want to find PT. We want to find the dot product. We remember this? We want to find the dot product of that vector. We know what that vector is, do we not? Because it was coming in parallel, so it's coming in at -3, -1. Agreed? So we're going to say PT dotted with -3, -1, and we want that to be 0 because then that makes it our perpendicular. Who remembers how do we actually find PT or TP? I can make that TP. PT, TP, because then it's going to be P take. Yep. So what's any point on this line? So Bethy's just come in, but we should be able to see, right, write a vector equation for the path of the aircraft. So that was B. So this bit here, this is telling us this represents the equation. So any point on that thing will be 200, take 120t, and 100 minus 40t. So that's what we're now going to do the dot product with. I don't know, I mean, that's the point. And so we go, the point, take 0, and so that gives us our technical vector. Okay, so it's going to be 200 minus 120t, 100 minus 40t, dotted with big old dot, scalar product, and we're going to solve for t. Keep in mind, what is it that we're actually asking? Find the time. So that's going to be what we do to find t when the aircraft is closest, and find the distance. So once you've found t, you will then pop that back into this vector and find its magnitude. Huzzah? Will the aircraft disappear from the radar screen? We obviously know it's before 1, but it's travelling all the way through. So what would we be solving? We want the distance to be greater than 100. Now, you'll get your 2 solutions, hopefully. One will be the 1, so you know that you're right. So it's going to have to be less than 1, and then you'll get the second solution, and it would have to be greater than that time if it keeps on going. And what did we all learn over the weekend or over the last couple of days? If you're travelling on an aircraft, keep your seatbelt on. Singapore Airlines. Saying for F, at what time will the aircraft disappear from the radar screen? We want the distance from P to T to be greater than 100. Now, in this case, remember, it's lovely that the tower is at 0, 0. So in that case, we're technically going, this takes 0. So once again, we get this doodad. And so it's that magnitude that we want to be greater than 1,000. So I'm going to go 200 minus 120t squared plus 100 minus 40t squared. And I want that to be greater than 100. Now, I could square root, but to get rid of the square root, I have to square, so I might as well just do that in one step anyway. Yeah? if you would like to just warm up with your mathematics this morning, by all means, you will expand. Oh, yes, they're big numbers, but we can handle that, right? Expand. You get everything on one side. You're going to have a quadratic in t. Okay, and so solve that. You can use your calculators for that. Or you can, how can you use your calculator to solve this even? You can solve n because you won't have the greater than, you'll just put equals, so you can go solve n, you'll get your two solutions and then do that. Now, technically, I would then require you, once you've got your two solutions, I would then use a sign diagram to show when it's greater than. Sub back in and you find, but we know from the diagram, we know before the 1, it's going to be outside the radar, and then whatever your other value is, it's going to be past that point. Agreed? So I think most of us are happy with, we're happy to find out the coordinates of A and B, A code for x-intercept and y-intercept, so that's all good. R is any point on this thingy here, so are we happy with express the coordinates of R in terms of x only? Yep, just rearrange, okay, so we end up with 3y equals 36, take 2x, and therefore we've got y equals, what's that, 12 minus 2/3 x, so therefore R will be x. 12 minus 2/3 x. Okay, some railway workers have set up their base camp at P, so P would be somewhere here maybe, 40, because what was that? Was that 18? 18, 0, and what was my y-intercept? 12. Okay, and so now we're happy to find P R because I'm now rewriting R as x. 12 minus 2/3 x. Agreed? So can we now find PR? Yeah? So I'll do that over here. So PR. I don't know if you're saying do it or you're killing us by doing stuff we already know. Am I doing? I'm doing? Okay. So PR, X take 4. And, oh, that's nice to be a 0, isn't it? Don't you love it when the zeros pop up? So that will be 12 minus 2/3x. There's me PR, my AB. Minus 18, so 0 take, and 12 take 0 is 12. We good with that? They could almost say, hence, find the coordinates of the point on the railway track that is closest to P. So basically, what we're trying to find is when is this any point, so whenever point that, when is that perpendicular? Okay, so we're wanting to go, when is PR, better do that, D. So when is PR perpendicular to AB? And therefore, that means we're going to go x minus 4, 12 minus 2/3 x, dotted with AB equals 0. What's the big difference here? We're solving for x this time instead of t. Now, this is where I would, depending on what you want to do you go, okay, I've got the idea now. I would now know what to do. Because I think a lot of it is, how do I know what I'm meant to do and what mathematics I have to use? When you get to this point, you might go, oh my God, yes, 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 I can solve this. 18x take 4 plus 12 times 12 take 2/3 x equals 0. I do know we're just chatting to another student and they were just saying, oh, got a funky answer, not sure if that's right. So sometimes finishing this off does give you that confidence that, yes, you can have some dodgy answers. But if you went, oh, yeah, I know what I'm doing now. Let me just try a different question to get that process under control, because I do understand your time is precious. With question 5, you might have vague recollections of your investigation from year 11. That's where it comes from. I make these up. So we've got boat A, and we had that was 3, where is it gone? So 3, -4 plus t minus 1, 2, and boat B was 4, 3 plus t minus 3 minus 2. Good with that? And I think everyone is happy. Yes, you can find your initial position. Yes, it's the first one. Can you find your velocity vector? That's the second one. Easy. Find the acute angle. Yes, so you're going to use your cos theta with this one and, oops, I put t. What was I meant to put? 2. 2. Now, remember when it said acute angle, what are we talking about there? So you either put the absolute value, just less than 90, correct? You put the absolute value around your dot product here, but if you didn't, not a major issue, just, yeah, if you got 100, well, take it away from 180 and therefore the acute angle would be 80. But if you've got your modulus around there, bang, it does it for you. Okay? All right, so the question was at what time are the boats closest together? Now, you can do the whole thingamajiggy what's it that we've done, but we haven't got a specific point. But remember what's going on here. So minus 1, what's A? Minus 1 going left and up. So A is going like so. And B is coming down like this and they're moving along. So, Sash, you might want to do, because they were doing this forever last year, but we want to find, if I can find AB, wouldn't that be the distance between them, or sorry, the position vector between them at any time? So if I find AB, that's going to be, so A to B, so 4 take 3 is 1 minus 3, take 1 is minus 2t, 3 take, we've got the 7 and minus 2, take 2 is minus 4t. Have to say that carefully, not 40, 4t, correct? So if I now find the modulus of this, what's that representing? The distance between the two boats at any time. So can I actually find the distance? Yes, I can. So we can go 1 minus 2t squared plus 7 minus 4t squared. That gives me my distance squared. And then how can I find the time when they're closest together? Well, you can expand minus b over 2a, because what you have learned in methods is that when you've got the minimum of something that's positive, the minimum of the d and the minimum of the d squared will occur at the same time, at the same time or the same x value, right? The y value would represent d squared, not d, so you still have to make sure that you square root. But again, in the age of technology now, and what you would have done last year is you would have actually just graphed the square root of that, g solve min, and that gives you the minimum x and t and the minimum distance, correct? So that will do that. Okay, now believe it or not, we get to skipperoonie a little bit, because what comes next is solving where two lines in space intersect, and it makes you do row operations, but we're going to do that when we do the planes, and we'll be able to interpret all of that the same. Then came the skew lines, coincident, whatever, and we've done that. So line stuff pretty much done. We are now going to go on to planes. The plane, the plane. So if you've got notes, a notebook, if you are doing it in your workbook, I suggest you have a new column, and we've got equation of a plane, not to be confused with the equation of a line. Setting the warning out there, like every little thing that we are doing at the moment, again, I think is quite simple. Doing that, you know, when we went back and we're doing, is it a line coincident? Are they parallel? Let's find out if they're skew or not, and then the angle between. When we're doing them, bang. Now we've gone on, done something else with velocity vectors. If I then said, oh, let's go and do that, oh, it's a little bit challenging. So do make sure you've got lovely notes, you've got it nice and organized, because now we're adding another, I would hope, reasonably simple thing. But again, so the equation of a plane, so we've got like a plane going on like this. When we had the equation of a line, we needed what? A point and? Slope slash direction vector, right? So on 2D, yes, point and a slope. In 3D, point and direction vector. For an equation of a plane, we still need a point, but the vector that we need has to be perpendicular to the plane. So we want this thing up here, we call this the normal vector. There's a little n there, and it's perpendicular to. Yeah? And what are we saying? You might be going, yeah, that's not normal. But how do we find a normal, a perpendicular plane compared to some others? The cross product. So that's going to come and play a little bit of a role for us. So we could have, you know, if we've got two vectors on this plane, and we know that we can get vectors from just finding the points. So if we have 3 points, we could then find the perpendicular vector if it's not given to us, and then away we go. Now this looks like a monstrosity, but it is not. So as a simple example, and there's one in your book, I'm just going to make one up right now. So e.g., if we had the point, I don't know, give us a point. Shall we just go 1, 2, 3? 1, 2, 3. And we're told, so we're told that the perpendicular vector, aka the normal vector, is, we'll go negative, maybe we'll go 5, negative 1, 4. Yeah? So we just go, this will be 5x minus 1y plus 4z. And to get what our d value, we just say, well, this is going to be 5 times 1 minus 1 times 2 plus 4 times 3. And we get our plane. So that, well, looks disgusting, but it's quite nice. Do we agree? So it ends up being 5x, take y, plus 4z equals whatever that happens to be. You might find the first couple of questions suspicious because they're so simple, right? Find the Cartesian, oh, by the way, sorry, the book goes through 2 different forms of the vector, and we don't have to do the Cartesian, so we will just do the normal vector form in our thingy. It just says in the ax plus by form, which is the Cartesian. There's another vector form which we don't have to worry with. So this is telling us this is our normal and this is our point. So suspicious by nature, but we just go, yeah, baby. So if you're doing this in your book, I would write normal equals 2 minus 1, 3. We've got our point, minus 1, 2, 4. And away we go. We go, well, that's going to be 2x, oops, minus 1y plus 3z You remember what we have to do? Now we just multiply these together. So 2 times minus 1 minus 2, take 2, 3 fours are 12. And we've got our equation. Ha, done. The next one, find the equation of the plane that's perpendicular to the line containing this. Yep, so find AB, and what we're saying is that that is, so we've got a plane here, the perpendicular to the line, this, which passes through A. So it means if we've got a line that's going through here, oh, mate, do my little, I'll do that better. My art skills. No, that goes through. So we've got A is actually here. We can go B is here, but that wouldn't actually go the other way. We can go B is here. This is the perpendicular. So A is my point. Find AB, which will be your perpendicular or your normal. Bang, sub, done. Does that make sense? Simples? Don't even sound same. So 2, 3, 1. What's our AB? So my normal vector will then be 3, 4, 1. Bang. So insult ski flying. State the normal vector then. So basically, what's the vector that's perpendicular to this? Well, 2, 3, negative 1. Sorry. Oops, I nearly dropped the mic then. I'm pointing. Sorry, that was 2, 3, minus 1. This one?
3 minus 1, 0.
I know. No Z means it's 0. And sorry, I'm just nodding to the class. You probably couldn't hear them, but they went 3 minus 1, 0. Correct. And what about this one? Ooh. 0, 0, 1. 1, 0, 0. I know. Okay. What about this one? Find the Cartesian equation of the XZ plane. Well, hang on. We want the equation. So let's think about, we want our XZ plane. But we're saying that this plane here, it can go out on X, it can go out on Y. So its basic one would be, what are we saying? Would you say? So the perpendicular to this plane here is our y-axis. So 0, 1, 0. And what's the point that is on it? 0, 0, 0. So that's your point. 0, 0, 0. So then when you put that into the whole bing bang thingy, we get huzzah. Okay, so we want the, sorry, what did we say? Find the Cartesian equation of the plane that is perpendicular to the Z axis. So as you guys said, yes, it is perpendicular then. We want the equation of the XY plane. But in order to find that, we need the vector that is perpendicular to this plane, which happens to be Z. Right? So that means my normal is going to be 0, 0, 1, and they gave us the point in the question, which was 2, negative 1, 4. Thank you. 2, negative 1, 4. Okay? So as they get, try and draw some of these and visualize what it is you're actually doing, because if you just read the question, I don't know if you're like me, but I just go, oh, Z, and I'm thinking, not the Z, so 1, 1, 0 something, but just, yeah, draw a diagram and it becomes clear as to what is perpendicular. Onward. And this is where, I don't know, is a little bit of maths coming in? Sure. Find the equation of the plane that contains these 3 points. And we're not going to bother, like this is the vector form, we're not doing that. We're just doing Cartesian form. So again, if we think about it, we've got a plane and we've got 3 points, A, B, and C. Didn't look very nice compared to A and B. C. And what we want is a vector that's perpendicular. So we know we could find AB and AC, and if we go AB cross AC, that will give me the normal vector, aka the vector that is perpendicular to those two lines. Those two lines both lie in the plane or on the plane, and so we get our normal vector. And we get that from our cross product. Will might decide to go BA and BC. CA and CB, sure. But when you are subbing into that equation, if you went CA, CB, you have to use C as your point. Okay, I just like to start with A. A for Ange. First point. And away we go. So I don't know. I'd like to think you don't need to follow the example. Once again, if you want to, mix it up. We've got technology that can now find the cross product. There could be a situation where it might be these vectors are perpendicular and you're missing one of these points. So you will have to make sure you still know how to do it by hand. So up to you how much you practice and how much you use technology. Is that okay? Away we go. I've already spoken to a few people about question 5, but for those that I haven't spoken to, and when you get up to it, find the Cartesian equation of the plane containing a point and a line. So again, I'm going to encourage you to draw diagrams if you can to help you explain. So we've got a line that's on this plane, and we've also got the point A. Correct? From this line, can't we say what our vector is? So this would have a direction vector of 1, negative 1, 2, correct? In order to find our perpendicular line, our normal vector, we need, So what we can do, we have A, which is 3, 2, 1, and that's the bit I really love, is we're going through, and as soon as I said, oh yeah, but we need a perpendicular vector, you then go, oh yeah. So those are the things you're saying to yourself as you're doing some of these questions. What do I need? Well, I want to find the equation of the plane. I need a point. I need the perpendicular plane, the normal. How do I find the normal? Well, we just did ones, we go to the cross product. The one we just did before, you had 3 points and you used those points to find one vector, and then we find another vector, right? Here they've given you one vector. How can we find one more vector? Well, pick a point on the line. And what's the easiest point to pick? Right, when t is 0, so 1, 2, 3. Oh, isn't that nice? Yeah? I was always in the habit, it doesn't really matter which one's going which, but you can find A, B, B, A. Technically, like I would have used the point B and you still get the same answer, but it does say that A lies on the plane, so maybe use A, same bizzo. Okay, so as we're going through, I can take it back to similarities with when you did equations of lines in year 10. You need slope, you need point. Well, suddenly they start going, well, I'm not just going to give you the slope. Right? They say, oh, I give you 2 points. And then you had to work it out. Same with this, okay? You might not be given the normal and the point. You have to sort of investigate and play around. So over the weekend, there's some people who need to do some catching up. I guess we want to try and work our way through. Some of them are going to be a little bit disgusting, so you might have to leave it and carry on. Some will be, oh, here's an example. Let's do one just like the example. So we are going through. Yes? I'm hoping that everybody can have a go at least up to and including 10. If you go any further, that's great. Or let's go 12, even dozen. Yes? And you might want to also, believe it or not, start organising your notes and make sure that all is well, because as we talked about before, you've got your mid-year exams that aren't that far away. Organisation is the key.